Hi guys, in our earlier video we had discussed about galvanic cell where we had used zinc as anode and copper as cathode. Zinc sulfate and copper sulfate were the electrolytes, alright, connected to voltmeter, alright, okay, and this was the reaction that occurred. Zinc plus copper sulfate giving you zinc sulfate and copper solid. Zinc solid, here zinc solid forming zinc ion, copper ion forming copper solid. So if we represent it in ionic form, it would be like this: zinc getting converted to Zn2 plus by getting oxidized by 2 electrons. So these 2 electrons are stripped by Cu2 plus to form Cu solid. So Cu gets reduced by 2 electrons, whereas zinc gets oxidized by 2 electrons. Fine. So this was our situation. Then we also talked about cell. We also talked about standard condition, and standard conditions were when we are using 1 mole concentration, 298 Kelvin and 1 atmosphere pressure. So when such is the situation for a reaction, then we call it as standard condition. Alright, and for standard condition, the cell that we had talked about was E0 cell. Now this E0 cell is equal to E0 anode, E0 cathode, and I told you that this symbol is for standard condition. Alright, okay. So for standard condition, this would be the situation. Then we talked about ECS. So that is the thing which I am going to pick up in this video. Now this is what is electrochemical series you have in your textbook. Now this electrochemical series, when you observe it keenly, you will find that this side we have got all the electrodes, alright, and if you keenly observe, you would find that it has got only the reduction potentials. Alright, so now here see Cu2 plus, I just took few examples which are required for our cell. Alright, okay, so this is Cu2 reduction, and this is the reaction that occurred. Cu2 plus 2 electron, that is reduction of Cu2 plus, and E standard E in volts is 0.337 volts for reduction of copper. Similarly, for reduction of zinc, it is minus 0.763 volts. Now this I just wrote here because this has got E0 is 0 for hydrogen. We call this as She. That is standard hydrogen electrode. Okay, now this was what I had explained earlier. Now let us get back here. Now here it is E0 cell is equal to E0 anode plus E0 cathode. Now E0 anode, as I mentioned here, in case of anode, what happens? It's the oxidation that happens in anode. But here we have reduction potential. So what do we do? I explained you earlier that we pick up those values. I'll pick up these values. I'll just multiply it with negative. Alright. When I multiply it with negative, what happens is it gets inverted. Alright. That is, as I had explained earlier, then it becomes oxidation potential. Alright. So here what I do is I write here minus of E0 reduction, alright, plus E0 reduction of what? This is E0 reduction of, this is E0 reduction, this one, it is Zn2 plus to Zn, and here it was what? It was Cu2 plus Cu, alright. So reduction of Cu2 plus to Cu, and this is Zn2 plus Zn. So I can straight away pick this value and substitute over here, but I have multiplied it with negative, so it becomes oxidation potential. Alright. So we took reduction potential, but by multiplying it with minus, it becomes oxidation potential, as I had explained in my earlier video. If forward is reduction then backward is oxidation. So forward is reduction potential and backward is oxidation potential. If forward has a certain value, say plus something, then the backward would be minus that same value. Alright, so same logic we apply over here. Now here it is reduction potential, so I just multiplied with minus, so it becomes oxidation potential. I hope it's all very clear. Alright, so what I do is I substitute that, I put this minus to convert the reduction potential into oxidation potential, and I put the value 0.763 minus. It is minus over here, right? And plus this is 0.337 volts. So the value comes to this becomes plus, so this becomes 1.1 volt. So this is the value that we get, and it is positive. Now keep one thing in mind, this value is positive. That itself means that the cell is spontaneous. Alright, the cell is spontaneous means the cell would be working. Now suppose if we would have changed, instead of taking zinc as anode, if we would have taken copper as anode and zinc as cathode, we would have got magnitude wise, we would have got, if I interchange magnitude wise, we would have got the same value, but it would have been minus 1.11 minus 1.1 volt. Yeah, minus, it would have been minus 1.1 volt. Alright, so see, just visualize this. So this I would have taken it over here, alright, and I would have done minus to this, so it would have been minus 337, and this would have been the reduction. This would have been reduction, since it's in cathode, zinc would have been in cathode, so minus, both minus. Alright, because this this was plus, so I had to multiply it with minus, so it would have been minus 337 plus. I hope you're understanding. This I would have taken it here. So right now it is anode. So anode means the value which is there, in order to convert it. So anode is oxidation potential. Now oxidation potential to convert to reduction potential, I have to multiply it with minus. So this value would have been minus, whereas this would have been reduction potential itself. So that also would have been 0.763 volts. So we would have ended up with this value. Now if it would have been minus, then we would have called it as non-spontaneous, that this cell won't be working. Alright, so this is about spontaneity and non-spontaneity. Now let us understand something about reducing agent and oxidizing agent. Just let's try and understand this. Now this was our reaction which we did. If we mention it in form of ionic state, so zinc solid reacting with CO2 plus, giving you zinc ion and copper solid. So what did zinc do? Zinc got oxidized. Oxidized means it lost 2 electrons. Oxidized means it lost electron. And how many electrons? 2 electrons. What happened to that 2 electron? That 2 electron was provided to copper. Alright, so zinc reduced copper to Cu0. So Zn0 gave its 2 electron to copper and reduced it. So zinc got oxidized, but acts as reducing agent. Why? Because it provided that 2 electron to copper, and copper took those electrons and got reduced. So zinc is reducing agent. Now in case of copper, what did copper do? Copper took those electrons, 2 electrons from zinc. So copper converted zinc to Zn2 plus. So it oxidized copper. So zinc reduced copper. So zinc is reducing agent. Copper oxidized zinc. So copper is an oxidizing agent. Alright. Now, so what do we talk about here? Now here, when this is She0, it has got 0 potential. Now when we go up here, we get value as positive, and here it is cathode. this is all cathode, down it is anode. So you have got to keep in mind this way. ECS, you don't have to by heart values, you just have got to keep in mind that highest plus value is for cathode and highest negative value, and if you want to put it as lowest negative value, I would call it as highest negative value since I'm saying negative, so is anode. This you have got to keep in mind. Alright, so what happens is 0, and then as it keeps on becoming positive and positive, that means it's becoming more and more cathode. More and more cathode means what? Cathode does what? Cathodes are oxidizing agents. So more and more it becomes a better oxidizing agent. Alright, as you go up. Whereas when you go down here, you are moving towards anode. So anode does what? Anode, what did zinc do? Zinc gave 2 electrons. Alright, so 2 electrons, and by doing that, it did what? It reduced copper. So the more you go down, it becomes the better and better reducing agent, whereas the more you go up, it becomes better and better oxidizing agent, because keep in mind, copper stripped electron from zinc, so oxidizing agent, whereas when in case of zinc gave 2 electron to copper, so reducing agent. So the more you go lower and lower in ECS table, the better and better reducing agent it gets, whereas it gets better oxidizing agent as we go up the ECS. Alright, electrochemical series. Fine. Now see, I'll just ask you a question. Now, for example, suppose a metal has potential 0.44 volts, obviously, and another metal has, say, plus 0.37 volts. Which you would choose as anode? This one or this one? Now see, when you see this positive, unfortunately I wrote it in series, I should have written 0.37 up. Anyways, so this becomes very clear cut. Now the more you go up, more up means more towards positive higher value. That is what is cathode. So this would be acting as a cathode, whereas here you are going towards negative side. So this becomes an anode. Alright, so what I'm intending to say is, you don't have to by heart the table, but you have got to know upper side cathode, lower side anode. So you can jolly well know which is a better reducing agent. So same way, if I ask you another question, out of the two, which is better reducing agent? We know when you go down, it becomes the better reducing agent. Think of zinc. What zinc did? Zinc gave 2 electrons to copper and reduced copper. So better reducing agent, better oxidizing agent. This stripped electron. So if the question is better reducing agent, then obviously this would be the answer. Anodes. Alright. Anodes supplies electron and reduces the counterpart. So this is better reducing agent, whereas this is better oxidizing agent. I hope the concept oxidizing and reducing agent is very clear. Alright. In my forthcoming video, I will be talking about, now we talked all about standard. Why should always the state be in standard condition? So I'm going to talk about non-standard condition. How do we calculate E of cell? At that time this 0 won't be there, it would be E cell. Alright, and that's what is Nernst equation. Alright, okay.